So the Doppler effect is a phenomena you can observe with both light and sound waves, and it relies on the fact that when there's movement between the source of a sound and the observer of a sound, when there's relative movement between them, the sound can appear very different depending on where you are and how you're moving. So if we look here first, you'll see we've got a stationary point source, and I hope you can agree that if we're looking down at it, we can see these sound waves coming from the source and they're emanating outwards. So as time goes on, the sound or the light, whatever it is they're producing, spreads out from the source. So far so good, but what happens if the source is moving? And so this is going to be a little bit tricky to see, but it produces a sound wave, okay? And the first one is just an ordinary one around the source. But when it produces the second wave, this one will have spread out. In the same amount of time, the source will have moved forward. So I hope you can see, even without me drawing it, that the second one, okay, as the source moves over, now this is our original wave that was first produced, it's just moved out from the source, and the source has moved, so the wave that it's produced is just a ring around it. And over time, what you get is a point source that's moving, causing the frequency, the wavelength, to be bunched up on one side and spread out on the other as the source is moving. So take a moment to kind of imagine how that happens. So there's a point and it produces a wave, and that wave spreads out. Okay, that wave front spreads out. In the meantime, the source moves slightly and produces another wave. So every time the source is catching up, so to speak, with the wave front. And so what you get over here is the apparent frequency, okay, the frequency that the observer sees is higher, and on this side, the apparent frequency is lower, okay? And you can hear this. This is why when you're, say, standing on the side of the road and a fire engine or an ambulance or a police car with their sirens drives past, as it's approaching you, it appears high-pitched, and as it's moving away from you, it appears low-pitched. So if you're standing right here as the source moves past, you will experience different apparent frequencies as it moves past you. And this is a phenomena that you're all pretty familiar with, hopefully. We're going to do some maths about it though.